Okay. So good evening, everyone. I hope you are doing good. I welcome you all in this session of calorimetry and thermal expansion. Today, according to me, it's going to be the last session of this chapter, but who knows? Okay. So let me just give you 1 minute. You will give me just a second. Okay. So in the previous lecture, what we have discussed about the state change curve and different processes that are going to be very interesting in changing the process or changing the state of any matter. Fusion, sublimation, resolution. So all of we have covered it. So and then after what we have covered, anyone? Calorimetry. Okay, which is very simple. Heat gain is equals to heat loss, and we have also discussed about the specific heat capacities. Okay, just a second. Okay, so today the topic, the agenda that we have covered today is not the calorimetry, but the name is suggested at calorimetry and heat transfer. So specifically, we are focusing on, just a second. Specifically, we are focusing on the heat transfer, and the modes of heat transfer. There are three modes of heat transfer that we have, so we are focusing on that. So in the learning objective for today is the conduction, convection, radiation, and Newton's laws of cooling. Although in radiation we will also cover Stephen Boltzmann law, okay, and we will see the Maxwell distribution curve or the radiation energy per unit wavelength. With respect to wavelength, we will draw that and see the variation of that. Okay, so cool guys. I think this is not the time to be cool. So yeah. Okay, so the first topic that we have is the conduction and convection. Now, what is conduction and why we are studying it, and what is convection, what is radiation, and what is the need of them that we are studying today. So in thermodynamics, the basic thing that we have is to transfer the heat. Okay, we are getting heat from the thermal reservoir, we are transferring it to do some work, and then we are rejecting it to sink. Now, one of the thing that we are missing out there, or we are not interested, and that is the rate of heat transfer. Now, how fastly or how rapidly the rate of heat transfer is taking place. Okay, that does matter, no? So it will matter to us that how fastly the heat is transferring from one place to another place, from colder body to hotter body. In case of refrigerator, like in how much minute or in how much time our water will be frozen. So that is the point. We wish to know that, okay, heat is transferring from higher temperature to lower temperature in the natural way, and lower temperature to higher temperature in forced way in refrigerator and heat pump. Okay, but wait a second, what is the time of rate of heat transfer? How much time it will take for a body to get warmer at 20 degrees Celsius to 80 degrees Celsius? Okay, because nowadays and in practical life, it is very important to know that how much time it will take to heaten up, how much time it will take to be cold. Okay, so that is why this topic has came into contrast, which is nothing but the heat transfer. Okay, now If we are taking interest of the time rate, we wish to know that how many ways we can transfer heat. Okay, so there are three ways to transfer heat. Firstly is the conduction, second is the convection, and the third one is the radiation. Okay, in in these three modes of heat transfer, we will study that which rate the heat is transferring. Okay, with respect to time. If we are talking about rate, it automatically means that we are chasing that particular physical quantity with respect to time, or we are see the changes in that particular quantity with respect to time. Okay, so that is our concern. Now specifically in this topic, in the heat transfer, in what is in your syllabus, so we are only focusing on the mathematical experimentation of conduction. Okay, because convection is very complicated thing, very complex thing, and radiation is also we are going to see, but most specifically we are focusing on the conduction and radiation, not on the convection. Okay, so the numerical answer type question you can expect only on from the conduction and radiation. But if I talk about the conceptual or theoretical question, so this has the probability by three of them: conduction, convection, and radiation. Okay, so in numerical problem, you will get a relief with this convection. Okay, now what is conduction? Firstly, we will study about. Now, what is the heat transfer? I have told you the transfer of heat energy from one place to one system to another system. Okay, and why this happening? Because of the temperature difference, higher temperature, lower temperature, so heat will flow naturally from higher temperature to lower temperature. Okay, so that is why we will say it, the heat is energy in transit. Okay, because when the temperature of both the system will become equal, there will be no heat transfer in that situation. Okay, no, the distinct mode that we have is conduction, convection, and radiation. So for example, this, how I illustrate this, if you will see, this is the fires coming up. Okay, but no means to us, just of emanation. If you put a rod of metal into it, so what you will feel? You will feel that after some time, the end that you are holding is getting hotter and hotter. Okay, and that much hot that it is not, we are not able to stick to it. Okay, so why is this happening? When your mom is cooking food and she has a big spoon type thing, na? And she has just stirring it and put it in there for a time, for a while. After some time, if you touch that thing, that big spoon, you will feel that it is getting hotter. It got hot. And how it is possible? It is possible because some of the heat is transferring into it. So what was that? That is the conduction. Okay, so in this example, if you will see, there is a metal rod and it is placed nearby this fire, the main source of heat. Although this end is not in directly contact with this heat, but after some time it is getting heater. Why it is so? Because the temperature of this side, because of the direct contact, will risen up, and due to this, the temperature of this end is higher, the temperature of this end is lower, so heat will transfer to higher temperature to lower temperature. So this mode of heat transfer, in which direct contact with the source has to be made, that particular type of rate of heat transfer or mode of heat transfer is termed as conduction, in which we need to make the direct contact. Okay, okay, so conduction is a mechanism of heat transfer of heat between two adjacent part of the body, usually solid, uh, because of their temperature difference. So we need to make the contact in between them. Okay, like this one. So this port is directly contact with this heat source, this metal itself, and you will feel this will get warmer and warmer with that as the time passes. Okay, it is happening because of the conduction. So on the interatomic level, what is happening? If this is the atoms, these are the atoms in the system, and this is where we have placed this system. So this atom nearby this warm place or this fire source is getting heater because of absorbing heat directly. So as they absorb the heat, which means the temperature of this side will rise up. So if the temperature is rising, you will know that the energy of that particular atom, which is 3 by 2 kBT, will rise. So energy increase with the increase in thermal energy or the temperature. Okay. Then this is nothing but the indirect form of kinetic energy. So if they are more absorbing more and more heat, the temperature will rise more and more. So as their vibration will become very vibrant. Okay. They are vibrating with a very more values. Okay. With more energy. So if this is the atom, this is another atom. Let's say. So due to vibration, this will strike to this atom more rapidly. Okay. This will strike to this atom. This will strike to this atom. So the rate of collision will increase. Okay. The rate of collision will increase, and that is why the rate of energy transfer will also increase. So this atom will transfer its energy to this. Then collision of this with this atom transfer energy to this. And since due to this is the continuous form, we are continuously supplying heat, so they are continuously transferring the heat to the another atom. Okay, and that is why we are feeling, if we touch this pot which is not in the direct contact with heat, it will feel hotter to us. So why? Because the atom vibrating here will transfer their energy to the adjacent atom by vibration. Okay. Now, in this process, you need to remember one thing more, that there is no mass transfer in this conduction process. The atom is there only, but it is only transferring the heat by vibration or by collision. Okay, it is there only. So atom as whole not been transferred to the another side. What it is same as if you have a pond of full of water and you throw a stone into it, so there are waves form into that. So although it will feel that water is coming out to the shores, but not, water is still there, only the energy in the form of these wave are transferring, only this disturbance is transferring. But it same as in the conduction process, although the heat is transferred to this atom here, it is getting more and more energy, so it will become more vibrant, make collision with the adjacent atom with a much faster rate, but it is not leaving its position. Got it? Now, one information that I also want to give you, that in conduction, there is a possibility that some of the material will conduct heat more rapidly than the other. So if I talk about the metals, they are good conductor of heat because they heaten uh, with respect to another material, they get heater, they get hotter and hotter rapidly. So why? Because the metal has the free electron. So as it absorbs the energy, this free the electron that wants to be free, by absorbing the heat energy, it will become free. Okay, so the free electron will transfer the heat from one place to another place in that system with a much faster rate. So that is why the rate of heat conduction in metal is very rapid than the another system. Okay, and that is why we have classified them into conductor and insulators. So into insulators may the heat transfer is not happen with much faster rate than the conductor. Okay. So if the question came that why the conduction is more rapid in metal, so it is because of the free electron of that. Okay. Now, if we have found it out that what is the heat conduction, that we want to formulate it, we want to see it in actual form or in mathematical form. So that is the heat conduction here. You can obviously guess this red hot system has a higher temperature and this blue has the lower temperature. Although in the upcoming slides you will see a question in which this scenario will reverse. For the better understanding, we have put this Tc is greater than Td. So if we place a metallic rod which is connected to this and this, but the rod is itself insulating, there is an insulation is providing to this, okay, so that the heat loss will not happen to the surrounding here. Now, if this body is at higher temperature, this one, and this is at lower temperature, so heat will definitely transfer to higher temperature to lower temperature. Now, the length of this will L and there is an insulation here. So experimentally, what has been found, that rate of heat flow that we want to measure, rate of heat flow, which is dq by dt, heat transfer per unit time, is directly proportional to what is the difference in the temperature and what is the area of cross section of this transferring medium. Okay, and inversely proportional to the length. Now I will tell you in a different way here. Look, the screen is visible to you, the black screen. Okay, so here let's say we have these blocks, which is here the temperature is T1 and the temperature is T2. Okay, and this is the metallic rod which is connected to it. This has a cross sectional area A. So definitely heat will transfer to this. So we can easily say that this transfer of heat is directly proportional to T1 minus T2 dq by dt or delta q by delta T. Much is the transfer, much is the difference in temperature. More is the difference in temperature, more the heat will be transferred. This we can automatically guess. This is not so rocket science. We can guess it. If the temperature different here, the temperature is 100. Here the temperature is 0. So, and in the another scenario, the temperature is 200, and here the temperature is 0. So, in which case the more heat will be transferred? In this case, okay. So, more is the temperature difference, more is the rate of heat transfer. Okay. Now, if I place, and you guys have to answer this, huh? If I place two rod of same cross section, this is rod number 1, this is rod number 2. Now, what will you say? The rate of heat transfer will increase or decrease? Here we have only one rod of this particular cross section A. Here we have two rod of the particular cross section A. So the rate of heat transfer will double because here only one cross section is attached to these blocks, and here we have two attachment, two cross sectional areas. Okay, higher the value of cross sectional area, higher the value of rate of heat transfer. So we can also say here that the rate of heat transfer is directly proportional to the cross sectional area, which is A. Now, if the same block I have taken here, so if I double the length, what will happen? If I double the length of this rod, what will happen? That the heat which is transferring from here to here have to cover more distances. Okay, so automatically the rate of heat transfer will decrease because now the path has been extended, na? And heat is a path function. So the rate of heat transfer will decrease. So we can say that here delta Q by delta T is directly proportional to 1 by L. If you combine these all, delta Q by delta T directly proportional to A, delta Q by delta T directly proportional to L. Then what will you get if you combine all of this? The delta Q by delta T is directly proportional to A upon L T1 minus T2. Okay. So delta Q by delta T is equals to K A L upon L into T1 minus T2. Now this K is nothing but the thermal conductivity of material, which depends on the nature of material. Now, what type of material you are using? You are using a conductor or insulator. Okay. So that is the thing I want to convey to you. So from that discussion, you can easily grasp it now that the rate of heat flow H is nothing but dq by dt or delta Q by delta T. So H is delta Q by delta T, or for differential form, it is dq by dt. So rate of heat flow is directly proportional to temperature difference, area of cross section divided by length. H is directly proportional to A Tc minus Td upon L. So for that, we can say that H is equals to Ka Tc minus Td over L. Got it? Anyone, any kind of doubt? If you have so, you can put this in the chat box. Huh? Now, what is K? I have told you, it is the thermal conductivity of the material. So unit is important of K, which is joule per second per meter per Kelvin. Okay. Or you can say joule per second meter Kelvin. Or joule per second will become what? Power. Power is nothing but work upon time. Work has a unit of joule, time has a unit of second. So joule per second is nothing but watt. So watt per meter Kelvin is the unit of K. Okay. Now, what the greater the value of K, greater is the value of heat transfer. More rapidly the heat transfer will take place. So it is more for conductors. Okay. Now what is steady state heat conduction? So the law that you have seen, na, it is also termed as Fourier's law. Fourier's law of heat conduction. Okay. Give me 10 seconds. So sorry for the interruption. So Fourier's law of heat conduction says that the same thing that we have discussed earlier, which is H is equals to dq by dt is equals to Ka dt over dx. And this should be in minus. Why this minus? Because this temperature difference, heat always flow from higher temperature to lower temperature. So that is why this minus has been came. So for minus sign, you will remember this thing. Heat flow from higher temperature to lower temperature. Okay. So this is the Fourier law, you can say. This is the Fourier law of heat conduction. Now, what is steady state heat conduction? So initially, if you connect, let's say these are the blocks of higher temperature and lower temperature, and this is the rod that is transferring that we use to transfer the heat. So initially, what will happen? The temperature difference is very greater. So due to that, this is the unsteady flow of heat that can take place. Okay, but when the difference of temperature is not so high valued, in that case the rate of heat flow, we will say it the steady state heat flow. Okay, for that we can say that if you take it, dq by dt is equals to ka dt by dx. Okay, got it. Now this you can note it down. Everyone note it down, please, because it is very important for the theoretical aspect. Let's say the temperature here is T1 and here the temperature is T2. Okay. Now, if you take the differentiation part here, that H is equals to Ka dt by dx. And if you integrate this term, H dx, K dt, if you integrate it, so the my voice is not clear. Right? It is because of the internet blockage. Huh? Now it is clear to you. So if I differentiate it for integrate it for 0 to L, the length of rod is here is L, and temperature is T1 to T2. So this will become, this is minus. So this is become minus H into L is equals to integration of dx will become 0 to L into L. Now this will become K T1 minus T2. So from that case you can say this will become H upon L upon K, H into L upon K, T2 minus T1. I have multiplied this minus to here. So here you can say that T2 is nothing but, or T1 is nothing but T2 minus HL over K. Okay. So this you can remember that if you plot the variation of temperature with the length, so it will be a straight line with the decreasing slope. Okay. This is delta T. This is L. Now note it down. Now, so here you can see the thermal conductivities of material. For silver, it is 406. For copper, it is 385, which means it is much higher values than ice, glass, concrete, and water. So they can transfer the heat more rapidly than ice, glass, concrete, and water. Okay. So that is why we are using these as the radiator, these metals. Okay. So this is metal, this is non-metal, and this is the gases. So for the information purpose, you can remember that the thermal conductivity of gases is less than lowest, and this is in between, and these are the highest. Metal has the highest value of thermal conductivity. Got it? So that is why if you see this question carefully, why some cooking pots have copper coating on the bottom, now you can easily answer it. Because copper can absorb more heat. The rate of heat transfer for copper, or the thermal conductivity of copper, is 385 joule per second kilogram Kelvin. Okay, meter Kelvin. Sorry. So if you coat any substance or any cooking pot with this copper, the rate of heat transfer will increase, and that is why there is a uniform heating that you will get, and your food cooks rapidly. Now, what is thermal resistance? So, in the heat current, in heat current, either you can write it in most of the books. This heat current is also written as QH equals to dH by dt, where H is the heat and Q is the rate of heat transfer. So I am writing it instead of that. Okay. Now, thermal resistance, we can use same analogy as current, as electric current. Okay. So in electric current, what is that? What is the thing? If you have remember, in your 10th class, you all have studied that. If this is the battery of V potential, and this particular has a load of R is the resistance of that. So we can say that if the current flow through is I, so we can say that this current, this voltage is directly proportional to the current, and to remove this proportionality, we will take resistance. So this R is the resistance of this system, which opposes the flow of current. Now V is the current always flow from higher potential to lower potential. In same way, if you will take heat current, so it is also flowing from higher temperature to lower temperature. So the same temperature difference we have. Okay. Here the voltage difference we have, due to which this electric current is flowing. So due to this temperature difference, the heat current is flowing. Got it? So there must be the resistance offered by this particular thing that is transferring the heat. Okay, allowing the heat transfer through it. This rod is allowing itself to absorb heat and transfer to the another system. So there must be some resistance offered by this. Okay, so what is that? We all know that this Q is equals to dH by dt. I am taking it here as this. Okay, Q is equals to dH by dt. No problem in that. Is equals to K A upon L T1 minus T2. T1 minus T2, which T1 is at higher temperature, T2 is lower temperature. Okay. So if I arrange this system in the form of V is equals to IR, so what will I get? Q is equals to Ka upon L T1 minus T2. T1 minus T2 is equals to, or T1 minus T2 upon L is the temperature gradient. I will talk about that. But if you will see here, T1 minus T2 L upon Ka into Q. And Q is nothing but dH by dt, which is the heat current. Rate of heat transfer is the heat current. In similar way, you can compare it with V is equals to I, 2 is replaced by I, and this is R. So this L upon Ka is nothing but the thermal resistance that we have. Okay. So by comparing that, we can say the thermal resistance RT is equals to L upon K. And you can easily guess, if you increasing the length of the rod, which is connecting to these two substances, higher temperature to lower one, two bodies or two system. If you increase the length, the rate of heat transfer will decrease, which means it increases the resistance. If you increase the value of cross-sectional area, in the same way, rate of heat transfer will get rapid, so that the resistance will go down. Okay. In same way, what is thermal conductivity? Thermal conductivity is it depends on the nature of any substance, and it is the ability of a material to transfer heat. So more is the thermal conductivity, more is the rate of heat transfer. Okay. So in opposite to that, if you take the inverse of that, what will be that? This will be the resistivity. 1 upon conductivity is the resistivity. So this is the thermal resistance. Now for series, note it down. For series, there are two combinations, series and parallel. For series, R equivalent is given by sigma RT. So which is R1 plus R2 plus R3. So you can say that if a rod of length L1 is connected to L2 length, cross-sectional area A1, this way. So this connection is termed as series connection. One rod, then another rod, then another rod, इस तरह से. That connection is the series connection. So this you can write as L1 upon K1 A1, L2 upon K2 A2, L3 upon A3 A3. This is the R equivalent for series. Note it down. Now for parallel, obviously the rate heat current, what you will say, Q is equals to Ka T1 minus T2 by L. It will only depends on the temperature difference, because in series the current is same. है ना? The current is same. The second one is for parallel. So we can say that R equivalent, 1 upon R equivalent equals to 1 upon R1, 1 upon R2, 1 upon R3. See, if you get the exact value, it will be 1 upon R equivalent, K1 A1 upon L1, K2 A2 upon L2. This one. Got it? Now, convection. So this is we have in conduction. The conduction part is over now. Now we will specifically talk about the convection. So what is convection? Convection is another form of another mode of heat transfer in which any substance which is getting hotter shift itself to transfer the heat. Focus on my word. Any substance, any mass has to shift to transfer the heat. Okay. Suppose you have a pot, you fill it with water and you put it on the burner. Now when water start boiling and you place your hand above this pot, so you are feeling hot, your hand getting warmer and warmer. Why? Because the water is converted into steam or vapor. That vapor is shifting itself in the upper one. They are moving up. Okay. So that is why they are transferring heat to your hand. But in that process, the mass itself has to shift. Got it? Take an example like this. Suppose this is the pot we have, and here is this is the direct contact of. So this is made up of any metal. This will get hot by conduction. Now the water adjacent to it will get heater and heater because of the direct heat transfer. But what about this part? What about this part? Now this part of water will become hot. So as water becoming hot, gaining temperature, the density of water will go down after 4 degrees Celsius. Okay. So this hot water will move up. Hot water will start moving up. To fill this space, this cold water coming down. This is cold water. So that is why the heat has been shifted to this point. Now you are understand. But in this mode of heat transfer, the water itself has to shift. Okay. So mass itself has to shift from hotter place to colder place. That is the only difference between conduction and convection. In conduction, there is no transfer of mass, but in convection, there is a transfer of mass. Okay. So convection is a mode of heat transfer by actual motion of matter, and it is possible only in fluid. For solid may you cannot shift the solid from one place to another. Solid mostly heat up or mostly gain heat because of the conduction or radiation. Okay. So it happens only for the fluids. It is very complicated topic, so it is given in a very short, very small concept of these are given to in your syllabus. Okay, if you go to entry in the engineering, either it is civil, mechanical, or chemical, you will have to study the fluid mechanics subject. In that, uh, fluid mechanics and heat transfer. So heat transfer is specifically a subject in mechanical engineering. Okay, in that particular subject, you will get to know a wide view of convection. But for now, you have to shift yourself to the smaller information. Now, convection, there are two parts of convection. Either it will be natural or it will be forced. Okay. Now, in natural convection, gravity plays very important role. Natural convection means you are getting the water heat, and you have instead of water heater, we will take the example of chimney. Okay. Most of the household have this chimney. So what is that? The air flowing through it, upon it, is colder. Okay. So due to this cold, the gases which is rising up in the chimney are hotter. So when they make contact with this cold air, they are transferring their heat to this. It will get cold, it will get warmer, it will shift itself. Then the fresh air will come. But it will happen naturally. Okay, happen naturally. But what if we placed a fan nearby to this chimney? If we place a fan, so we are forcing air to this. Okay, we are forcing the cold air to this to remove this hot air very rapidly. So that is termed as the forced convection. That's simple logic. This one you can take the example of convection, which is natural. Now, so natural convection is responsible for very familiar phenomena, the warm air, cold breeze during the day. So during the day, the direction will be this: warm air go to the cold air, but in the night the direction will be shift. Yeah. Now, in forced convection, material is forced to move by a pump or some other physical means. So we have a very natural example of the forced convection, which is our heart. So this way, the room heater that you bought nowadays in winter, this is the best example for forced convection. So you are forcing this cold air or the matter to becoming warmer. So this is the best example for forced convection. We are forcing matter to move. Okay. And the human circulatory system. Your body is at a temperature of 37 degrees Celsius. Why it is possible? It is possible of the circulation of blood. Okay. It is possible of the circulation of blood. Now, who is circulating this blood? Our heart. Okay. Our heart is a pump. We can say that. So this pump is forcefully supplying the blood to our body. So we can say that this is happening because of forced convection. The process is going on, is termed as forced convection. Okay. In automobile also, we have radiator and this cooling system. So we can say that this is also example of forced convection. Now radiation, the last topic of today's class. This is the conduction, this is convection. We got it well. What is conduction and what is convection? Now the very rapid and the fastest form of radiation. Now in conduction, what do we need? We need to make the contact to transfer it. In convection, we need the matter to transfer heat from one place to another. But what if we do not need any contact, if we do not need any mass? So that mode of heat transfer is termed as radiation. Okay. And it is the fastest mode of heat transfer. So it is defined as the radiation is defined as the transfer of heat by electromagnetic waves in the form of electromagnetic wave. So electromagnetic wave are the fastest wave that we have. They will travel with the speed of light, 3 to 10 raised to the power 8 meter per second. Okay. And we also know that the electromagnetic wave do not need any medium to travel. So that is why this mode of heat transfer is the fastest mode of heat transfer. And also it does not require any medium. Okay. Good. which means if you are place yourself in vacuum, then also you can receive heat with a very fastest way, which is radiation. Now, the sun rays coming to earth is the best example for the radiation. Okay, you can feel the warmth of this sun rays, the intensity of the heating. Okay, in summer specifically. So this mode of heat transfer is the radiation, but up to what extent? Up to when it is not entered in the atmosphere, because then some of the heat is absorbed by our atmosphere also. Okay, so this is the example, this important definition. So energy of the radiation transferred in the form of electromagnetic wave is called the radiant energy. Got it? This way. So we have seen that this is the electromagnetic waves in action. So electromagnetic wave is the plotted like this. This vertical, if you will say this blue line, is the variation of electric field with respect to time. And this red color wave, if you will see, it is the variation of magnetic field. So you will learn about this in your later in the upcoming class 12 electromagnetic wave chapter. Now, so according to a scientist or physicist that have made the common observation that all body emits the radiation, all body, even we also emit some kind of radiation. Okay? Although it is whether whatever the form of energy, whether it is solid, liquid, or gas, all bodies emit radiant energy. Okay? The amount of emission will not be that much higher or will not be that much lower. It depends on body to body, nature of the body. Okay. So the radiation that is emitted by a body, okay, by the virtue of its temperature, because although in heat transfer, what we are talking about the rate of heat transfer, which means it happens because of the temperature difference. So this is called the radiation, this luminosity, if you will see. Okay, and this is called thermal radiation because you have increased the temperature of this particular matter. That is why you are able to see this form, this radiation. It is termed as the thermal radiation. Now, the light bulb is the example. Now, what has happened when the energy is coming? It's partly reflected or partly absorbed. Okay. So till now, nobody can absorb complete energy. Okay. Practically. But we have established a body which is termed as black body. Okay. What it is called? It is called black body that emit and that absorb all the type of radiation fall into it and emits all the possible radiation. Okay, so we will discuss about that. Firstly, we will talk about this line. Good absorbers are bad reflector. So suppose this is the any material we have. Now a heat given to this is, let's say, Q. Some of the part Q1 is reflected by it. Some of the part Q2 is absorbed by it. And some of the part, let's say Q3, is transmitted by it. It is not reflected, it is transmitted. So based on that, we will study three terms, that Q1 upon Q is defined as, this is the reflective amount of heat divided by total amount of heat is called as small r. Q2 upon Q is called as, this is the heat absorbed, so it is A. Q3 is the transmitted heat divided by Q is the D. So this R is termed as the reflectance of body. Reflectance, reflectance of body. This A is called absorptance. Okay. And this T is termed as what? Transmittance. Got it? If you take, this is the example that R plus A plus 3 is always equals to, because R is nothing but the reflected. So whatever the heat it has reflected, whatever the heat it has absorbed, and whatever the heat it has transmitted, this material is always equals to the heat that is incident on it. Got it? So if you put the value here, R is Q1 by Q, it is Q2 by 2, it is Q2 by, Q3 by Q. So if you sum it down, it will become Q1 plus Q2 plus Q3 divided by Q is equals to 1. So Q1 plus Q2 plus Q3 is equals to Q. Got it? So this is the line. So if you increase, let's say for somebody, transmittance value is 0, which means that it is not transmitting any heat. So R plus A, you can say, is equals to 1 now. Now, if you increase the R, the A value should be decreased because the sum has to be 1, which means if a body is reflecting the heat, okay, R, increment of R means more reflectance, more heat is reflected. So its absorptive power will decrease. It cannot absorb that much amount of heat. But if I increase the value of A, the R will decrease. Okay. Increment in the value of A, which is the absorption, decrease the value of reflectance. Okay. Which means that is the line it is written here. If any body is a good absorber, which means higher the value of A, it is bad reflector, lower the value of R. Okay. So this is it for today. I hope you got it and you have enjoyed this session. Any kind of doubt if you have, you can ask right now. Up to this, the remaining topic we will discuss in the later on classes. Okay. Got it? Now, or I will also discuss it in the weekend classes by mentioning the topic name. So we will see it, whatever happens. Thank you so much.